Hello guys, good morning. I'm happy to see you guys once again. This morning I come your way with a very interesting topic, algebraic expressions. And in our previous lessons we discussed about algebraic expressions, what they are, how we can simplify them or merge them, how we can multiply or add, how we can add or subtract two or more terms. Now, I want to look at how we can multiply or divide two or more terms. Now, how do you go about this? Or how do you multiply or add? You first have to group like terms. And after the like terms, as you group the like terms, you apply the respective operation, which is the multiplication and division we have at hand. After which you apply the laws of indices, the respective law of indices, be it the law 1, law 2, or law 3, as the question demands. After applying the law of indices, you simplify. So now we want to take some examples and know how we can apply what we just have understood conceptually. We want to understand, we want to apply and practice some examples. Now, looking at example 1, we have 4p times 8p squared. So, like I said, you have to first group like terms. That makes it very easy. So in this first example, we want to take our steps and apply all the steps. 1, we have 4p times 8p squared. So the 4 and the 8 are constants. So here we have to put the 4 and the 8 in one constant, in one bracket or in one parenthesis, like this. Then in another bracket, when we have to open another bracket and put the variables p and the p squared there. This one, 4 and 8 gives us 32. Then the p and the p squared, we learned in indices in our previous lessons, that is before the sudden break. We learned that anytime we have the same basis, if we have terms or numbers which are written in index forms, and they have the same basis, we can add the exponents and merge the two. So right now we have p, and anytime you see a constant without any exponents, that means that particular base has an exponent of 1. But often we ignore the power 1. So right now we have p power 1 and then p power 2. And because they are multiplying, these are the same basis and they are multiplying, so we have to add the exponents as the law of indices demands. So we have p power 1 plus 2. Looking at this, we can now write 32 and write the p1 and p2 as p3, because when you add 1 to 2, you get 3. So this becomes our answer or our product for multiplying 4p and 8p squared. I hope everything went well. I hope you have full understanding. And I will definitely be awaiting your questions on the platform, and I will respond to them as soon as possible. I want us to look at the second example, example 2. We have negative 2a times 4c times 5p. Here we have 3 terms. We have negative 2a, that's the coefficient negative 2 variable a. Here we have different constant or coefficient for variable c. We have 5 and the variable b. So we can group the like terms. Grouping like terms. Here we have negative 2, 4, and 5 are the constants. So we put them in one bracket, like this. Then for the variables, we put them in another bracket. We have a, then we have c, then we have b. So looking at this, and it's always presentable and professional to arrange the alphabet in alphabetical order. So when it comes to this, We will first deal with the constants, then we come to the variables or the alphabets, the letters. Right now we have negative 2 by 4 giving us negative 8. And negative 8 by 5 gives us negative 40. So we write it here. Then we come to the second bracket which contains the variables. Here we don't have, here we have terms or variables with which are different from each other. They are not the same, so we can't apply the law of indices here because these ones are not the same. So here, anytime you multiply variables in maths, as we have learned earlier on, you attach them to each other anytime you multiply. So we just have to pick the A and bring the B and bring the C. This gives us our final answer, or the product for multiplying these algebraic terms. Good. Any question you have in mind, you can put them on the platform and I'll respond to you as soon as possible. We want to look at the third example. Third example. So here we have 5s cubed y 5x y power 2 times 4x power 4 y power 3. So as usual, you group your like terms. You group the like terms. So for the constants, you put the constants in the bracket. That's the 5 and the 4. Then for the variables, we also put them in another bracket. We have x times x power 4. We have y power 2 times y power 3. X and x, we put in one bracket. Y and y, we put another bracket. So if we want to simplify this, we get 5 times 4, giving us 20. X times x power 1. Here we can apply the law of indices, the first law of indices, because we have x and x, they are the same basis. So here is x power 1, like I said, we don't write the power 1. So here we have x power 1, and we have x power 4. And because they are the same basis, we can add the exponents, as the law of indices says so. So we have x power 1 plus 4. Then for the y, we have y, then we have power 2, power 3. So we add the 2 and 3. This gives us 20x, the 1 plus 4 gives us 5. So the x will now carry the exponent 5. Then y, 2 plus 3 gives us 5. So the y will carry the exponent 5. This gives us our final answer, or the product for multiplying these algebraic terms. Now we want to move on to the division aspect. So for question 4, we have 16a power 3 b power 2 divided by 2ab. Here we have two ways through which one can easily do this. The first one is the approach that I began with, what are the grouping like terms. And group like terms. This gives us 16 divided by 2. That's the constants will come in one bracket. Then a power 3 divided by a. A power 3 here, and the next one, a is there. Then b power 2 divided by b, as you can see here. So to simplify these, we have 16 divided by 2, which gives us 8. Then a power 3, and according to the second law of indices, anytime we have division sign in between two indices or two numbers written in index forms, and they are having the same basis, we can subtract their exponents or their powers and get one single term or index. So right now we have a power 3. Looking at this, we can a is power 1, so we will subtract the power 1 from the power 3 here. The b power 2 here is power 1, and because we don't write, Here we have power 2 here. So our final answer becomes 8a. 3 minus 1 gives us 2. So a power 2. 2 minus 1 gives us 1. So we have D. We don't write a power 1. Because any examiner knows that any number is power 1 if it's not indicated otherwise. So we want to take our last example, then we bring our lesson to an end. So now we want to take our last example and call it a day. So looking at this is also still, this one still has division. The operation here is division. So we are going to divide 50y power 3 by the 3y power 2. Here, as usual, we go by grouping like terms, include the like terms. So you put the constants in one bracket. Then the variables, we have y power 3 in the first term divided by y power 2 in the second term. This gives us 5 divided by 3 gives us 5. Y power 3, y power 2. According to the second law of indices, anytime we have numbers written in the index form like this, and they share a common base, we can subtract their exponents. That is the one on the right side of the sign, on the operation sign, from the one on the left side. That is, you have to subtract the 2 from the 3, as indicated on the board. This gives us 5y power 1, which we don't have to write. So this gives us our quotient, or the answer to the question above. I mentioned that we have another approach that we can use to still untie this knot. Let me quickly touch on it, so that you will choose the one you are most convenient with, or more you are well addressed with. Okay, so now we have, like I was saying, this one, for instance, we have the question 4. I want to take the question 4 again. We have 16a power 3 b power 2 divided by 2ab. The second approach demands that if anytime you see division, it means over. We can use division as a bar, as an over bar, the over sign. That is 16a power 3. This expression, you can rewrite this expression as 16a power 3 division, that is the over, 2ab. Then we will spread these indices, or these index terms. 16 will come. Every time you see dots, if it's not if it's not a decimal number, but you see one term dot another term, it simply means they are multiplied. And here we can't write 16 and the a in decimal as a decimal number. So when I write 16a and here is a power 3, you can write the a power 3 as this. And if you have to apply the law of indices and get back to the a power 3, we just add 1, 1, 1 and we get the a power 3. So we can rewrite the a power 3 as this. The same way we can rewrite the b power 2 as this. Then the 2ab also comes in. So this 2 can divide itself by 1, can divide the 2 by 2, getting us 1. Then we divide 16 by 2, getting us 8. 1a will take away, this a will take away 1a in the top there, in the numerator. This b will take away 1b. This gives us 8a dot b all over 1. That is, our final answer becomes 8a power 2. That's a repeating twice. That's a squared, and then b is 1. So looking at this, we have the same answer as we had when we used the first approach. All right. Finally, we use this approach for the question 5, and bring this lesson to an end. So question 5, we have 15yk, or y power 3, divided by 3y squared. We can rewrite this expression as 15y or 3 all over 3y squared. And we can rewrite this 15y upon 3 as y dot y dot y. It's multiplying 3 times by itself. 3y power root y. 3, we can choose a common factor as 3 as a common factor. 3 can divide itself 1, can divide 15 5 times. Y, this y will go away with this y. This y will go away with this y, leaving only one y over there. So top here we have 5 and we have y. These ones have been cancelled out. Over 1. This gives us 5y. The number over 1 is the same number. So you see, we have actually gotten the same answers we had when we used the first approach. I hope you really enjoyed this class. I'll await your questions on the platform. Kindly let me know whatever challenges you have, and I will urge you to solve more examples, more questions in other books. I will meet you in the next lesson. I've put some questions in the lesson notes. Do your possibly best and solve them and get back to me. Bye bye.